The topic, tangents and secants to a circle. We all know what a circle is, a round shaped figure which is equidistant from its center. Now coming to the introduction, the word tangent has been introduced because when different structures were studied along with respect to a line, then the line was either touching or intersecting or non-intersecting, is how we conclude. But before we enter into this topic, let's come with the introduction of tangents and secants to a circle. Now to start with, the straight lines, which we already discussed in the previous session. The straight lines had three different cases. Let's recap with the straight line cases which we have introduced in the previous sessions. Now the straight lines were identified either to intersect, the line L1 is said to intersect L2, or the second possibility was the line L1 was parallel to L2, and the third possibility was that the line L1 and L2 coincide. So there were three different cases we have taken in case of straight lines, either intersecting or being parallel or non-intersecting or coincident, intersecting at infinitely many points. So as we had three different cases arising out of two straight lines, also we have a curve and a line coming out with three different cases. The possibilities of a curve and a line arising with three different cases was, say for example, if I study the two lines intersecting at a unique point, then if I have a curve, so this is the curve C, then the line is either going to be intersecting. In this case, we say a curve is intersecting the line, and in this case, we say a curve is touching the line, and in this case, we say the curve and the line are non-intersecting. Is how we have three different cases which we can compare with the three different cases of straight lines. So the possibilities are that the curve and a line may intersect, may do not intersect, or may touch at one point, or touch, the curve and the line may touch. So these three different cases have risen to the topic of tangents and secants to a circle. Today we are going to study about the circle and the different possibilities of a line which cuts the circle, do not cut the circle, or touches the circle are the three cases which we are going to study in the session of tangents and secants to a circle. So let me consider a circle and a line and see how different cases arise as seen in the previous session. So considering a line and a circle, initially to start with, the case 1 where I have a circle with a suitable radius and then I have a line which does not intersect. So this is the line L and this is the circle which I denote with this. So for a circle and a line, here the possibility is that the line does not intersect the circle. Now the second case is where I have a circle and a line which cuts the circle. So here the line cuts the circle, here the line does not cut the circle or does not pass through the circle. And the third possibility is that a line touches the circle, is how we study the three different cases. In this case, the line touches the circle. So here we have three possibilities of non-intersecting, intersecting, and touching. So usually I refer this as non-intersecting. I refer this as intersecting, of course, intersecting at 2 points. And I refer this as touching because the line touches the circle here, the line intersects the circle here, the line does not intersect the circle here. So in this case, these two are a very special case which we take into consideration because when the line and the circle do not intersect, then we mathematically we assume that the line and the circle have no relation because they do not intersect. In case of this and this, we have many mathematical properties which we are going to study as geometrical understanding of the line and the circle intersecting and touching. To come with the intersecting circles here, if suppose I have the 2 points P and Q where the circle is intersecting, then this line segment PQ is called the chord or the secant of the circle. The chord or secant of the circle is what we call the line segment PQ. So for an intersecting circle, we have the chord and or the secant for a given circle. So here PQ is called chord or secant of the given circle. So the line segment PQ is called the chord or secant of the given circle. And as I identify, the chord or the secant is always less than the diameter, because if I take the diameter, then the diameter is the maximum chord. So geometrically here, I understand that the diameter is the maximum chord. The length of the diameter is the highest chord out here. So if I take a note here, diameter of circle is the maximum chord of circle. The word maximum because the diameter is that length where we have the highest segment of the circle. And if it acts as the chord, then diameter of circle will be referred as the maximum chord. So coming to the chord and secant, let's switch on to the touching circles, where if suppose I say the line touches the circle at say point P, then I call the point P as the point of contact, and the line is said to be a tangent to the circle. It's very important that when a line touches the circle at single point, then the chord is 0 because there is no secant or chord. Therefore, length of chord or secant is assumed as 0 in case of a line touching the circle, because this P and Q tend to one point is how we understand. So when P and Q tend to one point, then we get a tangent. So therefore, for touching circles, we say that the two circles touch when chord tends to 0. When chord or secant tends to 0, then we get a tangent out of a secant. So an intersecting concept reduces to touching concept if the chord reduces to 0 or the secant reduces or tends to 0. So this two converge at a single point, and here in this case, if the chord tends to 0, line L is called tangent.